Hello everyone, welcome back. Today we are going to discuss on the path vector algorithm, and also we will explore the things like what is you mean by BGP protocol. So come on, let us explore what is the. So you can see here it uses BGP protocol. So it is a vector mechanism. Let us understand step by step in detail. So when it comes for path vector, so this explores the algorithm, the methods of finding the large scale networks. If the network is very huge, then you have to use the BGP protocol, which is a gateway. It is a device that connects the largest systems together. In such situation, we use the path vector algorithm just to find out the shortest path in the network. So this is a route as we show you the example, like if you want to find nearest route for shopping or any other applications, then you can go for this, right? So path vector algorithm uses is an interdomain routing that allows the different systems to communicate effectively. So if you want to extend this distance, it improves routing efficiency, maintaining full path information. So if the distance of the path is high, then it maintains the efficiency. Then if there are more number of loops, as I shown in the previous example, I'll show you here. Yeah, this is a route. So here there are number of routes, right? This we call it as a loop. A person can reach from here to here, here to here. So if the same thing happens, then there could be a duplication of data. So that duplication can be avoided. That we call it as a loop prevention in the vector. So what is a foundation is a gateway which acts as a vital backbone for internet in the large scale routing information. So let us understand what is the need of path vector algorithm. So first thing what you want to know is the count to infinity problems. So problems occurs when incorrect routing, when incorrect information is given, when incorrect path is given, we are not able to find out, and there will be delays in the network, so data could not transfer. So this overall affects the network performance, right? That is why we use the path vector algorithm, which uses BGP. Then slow coverage in the distance. So when you start routing the information, or when you send the information to the table that is in the router table, which may result in the duplications of data or inefficiency due to maybe the less band width of that, or if you are using the outdated one. So then loop prevention, as I mentioned earlier, you can see here. So same data may be reached several times, which creates a loop. So data will be roaming around the loop and it takes much time for reaching. So that is why we have to use the path vector. So now working on the principle of path vector, we'll just go and explore how it works. So here is a thing that router keeps the path. So we know what is a router. It just routes the information from the routing table to the different neighbors. It just finds out who is the nearest neighbor, and it route back the information to prevent the routing loops. So if there is any loop, so it will reject. So if there is a shortest path, it will select the shortest path. And then we have as an example, so I have given you an example illustrating some path. So just I'll zoom this. Yeah. So now here you can see from A to B we have one path, then B to C, C to E, and C to D. So this is just an example. I have taken a small example because if I take the original real-time example, then it may be a difficult. Now from A to E, if I want to reach C, the data can be reached in this loop also, as well as it can reach in this also. So what we have done is just to remove the loop, that we call it as a spanning tree. Now how can A travel? So A to B, B to C, C to E, and from B to E. So these two things we will remove so that we update the information. Similarly, how B will travel? So B to C, C to E, B to D, and B to A. So each things we will keep on updating the table. So after updating, you will get this like this. So A tree, so before it was like this, how A reached A from B, B to C, C to E, and B to E. So there is no loop. So if I draw a line here, it becomes a loop. So it avoids loop. Similarly, B, how B will travel? So we'll make B as visited. So B to A, B to C, B to D, B to D to E. So no two a spanning tree, we call it as a, because without loop, no two routes look similar, right? Now we'll take from A point of view. From A, if I want to travel any distance, from A to B I'll travel, from B to A I'll travel, then D and then E. We cover all the routes. Similarly D, from D to B, B to A, then D to E, D to C, then E, E to C, E to D, then E to B, A. So now when you look at this graph, this was the route, original route. Later on we converted that into this route so that there will be no loop. This is the main aim of the path vector algorithm, finding the shortest path without any loop. Okay. So then what is the difference? There is two algorithms. So distance vector also you can refer my previous videos, so you will understand what is the distance and the path vector. Now we are bringing together what is a distance vector algorithm. So distance vector focuses on the distance, okay, whereas the path vector gives the full information about the path and as well as the strong looping prevention, path check. So distance vector coverage rate will be slow, whereas this highly scalable. You can scale the distances. And this distance vector is not robust, means not that much offer because it does not use this BGP. Whereas the path vector, since it uses broad gateway protocol, so it covers the distance, faster coverage, and it reaches the maximum distance with slower rate. So now where we will use the path vector algorithm. So here, in internet routing, for example, so many people, so many internet connections are there, we have to take the routing decisions. There we can use the broader gateway protocol. Then advertisement, so each anonymous system then shares the information, so they try to prevent the loop. For that we can take a path vector algorithm for looping decisions. And then flexible routing policies, like we have a flyover, we have so many routes together, so we want to fix a route in such a way that no person should come in the same route, or no person should go in the same route. In such cases we can go for this flexible routing policies using broader gateway protocol that comes under path vector. So now what is the advantages? As advantages is considered, prevents routing loops. Yes, we saw that there is no loop. Okay. Next is scalable for internet routing. So you can use that. Next is supports routing based policies. So you can take the decisions based on this criteria, based on the preferred routes. And faster coverage. So if you want to cover the internet at a faster rate, distance, then it allows quicker adapting and changes to the networks, so that it will do it at a faster rate. Okay. Next is what we have is the disadvantages of the path vector algorithm. So what is the disadvantages? Each and everything will be having its own advantages as well as the disadvantages. So the disadvantages, it requires more memory because it has to store the shortest path and then it has to find out. And then bandwidth. So for routing decision, it requires bandwidth. Then if the speed is lagging behind, then the protocols, everything, it will take a lot of time to do that, to find out the shortest path. Suppose if you have a topologies like star, ring, or positioning of this topology or systems, for that it may take more time for doing such kind of task. Then applications, already we have discussed the disadvantages and advantages. Now we will go for applications where you can, so key roles in the BGP. So this, what is a key role of BGP, we will be studying in the next upcoming video. So thank you so much for watching. Please do like, subscribe, share and comment. So this is all about path vector.